Well, welcome to your first lesson in Workplace and Apprenticeship 30. Today we are going to look at 1.1, which is something titled Linear Relationships, which is something that you've dealt with your whole life involving math. And all that we're going to do is we're going to apply it to some new terms. The basic idea being that it's a relationship between two things. And a simple example is up on the board here. What if you could trade one cow for 3 sheep? Well, then logically, that progression would continue that if I had another cow, well, then I could get 6 sheep. And we see it all the time in our world. Probably the best example would be with regards to money, and we're going to look at that in a minute. So there are some definitions here that we're going to run into in this assignment. The first is a linear relation, which is a line. A straight line on a graph is a linear relationship. And you're also going to look at the slope of a graph, which is called the m value, which is the change in the y value or the change in x. That's kind of confusing, so I usually end up calling it just your rate of change. And that just simply means as one value goes up, how is the other value affected? And the last definition here that you'll see that you'll be writing down in a little bit is a direct linear relationship. And you can see that that's one that's going to go right through the origin being the coordinate 0, 0. Let's take a look at this example with Cheryl earning money. She is a wage earner, which means she's not earning a salary, but a wage of $11.25 per hour. And when we have that situation, there is definitely going to be a rate of change. Now that rate of change, which is called your slope, is the amount the y value changes, which in this case is the earnings. How does that change every time the hour goes up? And when you're talking about a wage, your wage is your rate of change. Your rate of change is your slope, and that is $11.25 per hour. With every hour that goes up, the wages earned stays the same, but the amount that you make increases as time goes on. So a good question to ask then is, does the time depend on the earning, or does the earning depend on time? And I think we would all agree it's the second, that the earning depends on the time. So what we would then call the time is the independent variable. And the definitions are in your textbook. Independent mean once you choose or have the time, the earnings are a product of that. It's not the other way around. So here's a picture of the graph of the earnings, and you can see it's a linear relationship because it is a line. It's a direct linear relationship because it starts at 0. And we could use this graph to answer a number of questions, maybe not being exact, but we could estimate if they were asked, well, how much time do I need to work to earn $40? And you could, well, you go to $40 and go across your page and then down, and you could say, well, it's about 3.5 hours. And we're going to use graphs to help us explain that. There are some important things, though, when I look at a graph that I'm going to expect you to see, or I'm going to expect to see, pardon me. This graph does not have its axes labeled. So when you make a graph in your assignment and for your check, you need to label your axes. This is the earnings, and it's measured in money. This is the time. It's measured in hours. And you should also have a title on your graph. This is Cheryl's wages or Cheryl's earnings, something that applies to the situation. So you got to be neat. You can use a straight edge. You can use grid paper. I've got lots, and you'll be graphing. Now, not all linear relationships will go through 0 and 0. Lots of them will start at a different value, and these are called partial linear relations. And here's an example of it. Charles owns a catering company. No matter what, he's going to charge you $250 for sure, and then $15 per plate after that. So when you go to your grad banquet, I don't know if you guys realize it, but you pay per plate. I'm not sure if the caterer charges a flat rate as well. So if we let that be a table, Here's what it would look like if I went from 0 to 10 to 100 to 200 people. You can see that every time the number of people goes up by 100, the cost ends up going up by 1,500 because it's $15 per plate. And then you add that 250 in afterwards. If we look at the graph of this, you can see the key thing for a partial linear relation is that it doesn't start at 0, 0. This one starts at $250 and then goes up at a constant rate. And again, what's the rate of change in this case? Well, the rate of change, which we let be the m value, is often written as, well, that's the change in the x value or the change in y value over the change in x. In this case, we're talking about the change in the cost over the change in people. So as the number of people increases by, let's say, 100, how much does the cost change? Well, we just said that's 1,500. So 1,500 divided by 100 is $15 per person, which we already knew because that was the charge per plate. However much it's going to go up, that's your rate of change, that's your slope. So what have we learned? A number of different things, including definitions. On the side of your page, there were 7 definitions on the margins. You need to write those out neatly onto a separate piece of paper. Also on a separate piece of paper, you're going to need to do the Build Your Skills assignment. And when you have a question about the questions, you need to ask that. Otherwise, you will not get them answered. And then you're going to do a check, and you're going to meet the level which you have set for yourself. If you do not meet that level, you're going to have to do it again. And preferably you will do it to your best ability the first time, and then you won't waste mine or your time. And you'll find a lot more success, and you can get the course done earlier. So that's the whole thing. For section 1.1, you can get right to work, and I will be here to help.